In this video, we're going to be going over the cybersecurity introduction room on the pre-security path on TryHackMe. The cybersecurity introduction room is actually the first thing that you'll conduct whenever you are doing the pre-security path on TryHackMe. And it's super quick and easy. It goes over all just, the broad strokes on the cybersecurity fundamentals, I guess you could say, whenever you're going through this pre-security path. So of course, you can see that there are three sections. We have web application security, network security, and learning roadmap. And this doesn't, again, if you are a bit further into your cybersecurity journey, you don't even have to be that much further in. A lot of this is going to be very easy to you. And that's perfectly good. This can be a great review for you. If you are coming into cybersecurity and you haven't gotten crazy deep, this can be a phenomenal learning path for you. And this room specifically will be kind of a great way to get the wheels spinning. It'll kind of show you, the possibilities in cybersecurity. It'll show you some of the offense and defense sides on this room. And so we're going to dive right in. First is obviously web application security. So why do we need to understand how the web is important? To attack web applications, you need to understand how they work. Hacking web applications isn't some magical process, but does come down to knowing how a part of a web functions, or how a website functions, and being able to identify weaknesses and take advantage of them. Once you have a good understanding of the fundamentals, you'll learn how the techniques, tools, and procedures are used in hacking sites. If something is vulnerable, it means that there's a possibility of it being attacked or harmed. If an application or system has a vulnerability, there is something that can be attacked or taken advantage of, aka a weakness. Now you can see I've already added the answers in or completed this, so I'm gonna go ahead and reset the progress just so we have some level of suspense. So spoiler alert, if you saw some of those examples. We're gonna go ahead and click view site. If you are new to TryHackMe, this is super cool. You can see it will literally pop out like a little website. And then if you have a subscription, I believe you should be able to pop an attack machine on a separate tab, and you can actually use that to complete some of these courses. So part one, you literally just need to check the website. Done. So easy, right? So what is the username of the Bookface account? I wonder, they should change this to continue to be a play on words, right? Like Zeta, or I don't know, whatever account you'll be taking over. So reading through here, you're an ethical hacker and it's your job to test for security vulnerabilities on Bookface. Let's look at taking a user account. Super cool. So we see Ben Springs. Here's his user account, and we can see here in the URL, it specifies the user in the URL string. So what is the username? It actually has the username here at the end of the URL. So we'll go ahead and put in ben.springs. That is a correct answer. Super easy. And you might actually notice this in websites. I think the more that you start to play around with web applications, a lot of things will start to make sense. I know for me, I don't really have a background in web application hacking, so seeing a lot of this stuff has been kind of relatively new to me. But the more that I've played around, especially with TryHackMe, I think it's a phenomenal platform to do that. See, you can see, but users have public profiles. It's common for attackers to target a password reset functionality to look for issues to gain access to user accounts. So here we have the reset password function. So you'll be emailed a 4-digit code. Enter Ben's username. So we'll go ahead and enter ben.springs because we already know that. The account reset usually sends an additional code to the user's email to verify that they have triggered the password reset. Sometimes you might actually see this come into your email and it just kind of if you haven't triggered, the code to be sent to you via the password reset functionality, and then you see that code come in, then that might be a cue. But that being said, sometimes attackers will write up phishing emails that will look like it's a 4-digit code, and it's not. It's a phishing email. So do be careful whenever you see those either way. So he will have the 4-digit code. We won't have access to the email. How do we get the code? There are 10,000 different combinations of codes, and we can enter it literally just doing that. Try and putting it any random reset. So we'll start with 0000, submit. We're literally, what it's suggesting is manually brute forcing this. If I remember, whenever I was going through this the first time, it doesn't make you brute force too high. So that's kind of what, whatever, we'll move on. It's really, what it's basically doing is telling you to try brute forcing it, and then it'll show you the web request down here. So you can see the reset code. It'll basically combine the reset code and the username in the post. So it's not going to be possible to guess every single code because that's going to take forever. But you can automate this process using the repeater and you can do this in Burp Suite. So it's going to tell you basically start with a minimum of 0001 and then 10,000, minimum of 1 and max 10,000. So we'll go ahead and do that. And it's literally going to brute force for us. And then here we get the reset code of 0187. And then we will go ahead and reset the password. We'll just call it password. Cool. And then there you go. You get the flag by brute forcing. So fairly easy. You just have to get that username right, which I was totally, I was adding in the S at Springs. So, or, saying Springs instead of Spring. So don't do that. Anyway, network security. Why networking is important. Networking is really important to understand in cybersecurity, from scanning and identifying who and what is on a network to reviewing network logs to monitor and track what users have been up to will require you to have an understanding of how networking works. TryHackMe's complete beginner learning path will walk you through the networking concepts and give you enough knowledge to get started on your cybersecurity journey. Super easy. So let's go and hit the site. And that gives us the first one. So this is really just kind of showing, I'm sure all of you might remember the 2013 Target hack. It was pretty huge. And then here we go. It's kind of like walking through, how exactly it, they targeted an air conditioning unit. Then from there, they were able to gain access to, other systems because it was networked. So that's why Internet of Things can be kind of dangerous if you're not networking them in a secure fashion. And obviously, if you're not changing the default credentials, changing the default credentials is a pretty big deal security-wise, because a lot of the default credentials are publicly available. Anyway, yeah, pretty big impact here. Not good. Big bad. How much data? Oh, it cost. What was it? It was like 300 million. Yeah, too easy. And then the learning roadmap. Let's go ahead and close out of here. So here, you see that the pre-security path, it'll kind of get you primed, and then you can choose to go the offensive route or the defensive route. Or really you can dip into both. I mean, how you choose to niche down in your career is totally up to you and based on the things that you enjoy doing. At present, I've been on the defensive path. Medium to long term, I'd like to dip into the offensive path, but there's most of the jobs you'll probably find are, in defense. There's a lot in, the pen testing side, but, you'll find this is, a lot more competitive than, a lot of the defensive, roles, just because a lot of people or a lot of organizations are trying to hire on people to be on SOC. The teams for defense might be a heck of a lot bigger than the offense. We're going to be going through the learning networking fundamentals path on TryHackMe, and we're actually going to start with the what is networking room in this video, and that's going to help us understand kind of the basics of networking, some of the methodologies, and just kind of the broad scope, big picture details about networking. So whenever we start to dive into some of the other topics, especially whenever it comes to cybersecurity, it's all making sense. And we're going to get started on all of that right now. So here you can see the networking fundamentals path is the second path that you'll have to do. And if you haven't already seen the cybersecurity introduction room, we completed that already. So definitely check out the channel if that is something that you are interested in. But now we're going to be diving into the network fundamentals path. And specifically in this video, we're going to be going through what is networking. And this will give us the fundamental picture on what networking is. So what is networking? Well, it can be found in all walks of life, as they say. The public transportation system, how is it that buses are being tracked by your central command and control node that allows them to be able to track, okay, this bus is on time, this bus is late, this one's ahead of schedule, these drivers are going to be off their shift here in a minute, these ones are coming on a shift, how we get these buses in. It's a giant puzzle, and it all requires networking. Infrastructure such as the national power grid for electricity. Absolutely. Again, and a lot of this kind of stuff, it requires, some sort of command and control. And in order for you to be able to, command and control, you have to have networking with your endpoints. Meeting and greeting your neighbors, pretty basic. And a lot of this is a bit more theoretical. You might even, if you want to say hey to them online, that requires networking. Then postal system for sending letters and parcels. If you have, some method of tracking that online, then it requires some amount of networking from the different facilities that your parcel is passing through. But and I think it's talking here just about like the idea of networking, but there's like actual networks, like computer networks involved in these as well. So it can literally be formed anywhere from 2 devices to billions. And by billions, we're talking about the wider internet. The internet is a network. It's a giant, that's why we call it the net, right? The internet, it's the network. These devices include everything from your laptop, phone to security cameras, traffic lights. And if you go to like Shodan, you can actually see some of these devices that are publicly broadcasted or accessible to the internet. It's kind of freaky. So definitely be careful if you have, like security cameras. A kind of a famous and frightening example is like a baby cam. Sometimes people don't change the default passwords on their baby cam, and then they don't realize that their baby cam is accessible to the internet, and people find that. So that's very scary. I mean, obviously change the default password, but do try to make sure that it is, not exposed to the internet. You'll have to edit that in your router. So we'll take this diagram and let me go ahead and reset my progress here before we dive in. Spoiler alert. So what's a key term for devices that are connected together? Networking. Beautiful. What is the internet? So we've established kind of what a network is, but the internet is basically the giant network, right? And you're combining different, we like smaller networks. You can, think of those as like a subnet, but like smaller networks that like, let's say an organization has, and then like your small like home network, and it's networking all of those together so you can all access, different resources. It allows you to basically go to like Facebook, or it allows you to VPN for work, stuff like that. So, we have all this text here. I know a lot of you guys were kind of saying, hey, just summarize the text. Basically, that's what we're talking about. We're going through the history of the internet right now. And the first iteration of the internet was the ARPANET in the 1960s with the DoD, the U.S. Department of Defense. But again, it took a little bit longer for it to be an actual internet that we know today. The actual internet, the internet that we know today, invented by Tim Berners-Lee, and that was the creation of the World Wide Web. Here you kind of see what I was mentioning earlier, where you have these different networks that are all networked together in the internet. That's really what the internet is. It's just the giant network that networks other networks. How many times can we say networks on this stream? Not enough. So who invented the internet? Tim Berners-Lee. I spelled it right. So good. Terrible. Unacceptable. Identifying devices on the internet. And I'll view this site here in just a second. To communicate and maintain order, devices must both identify and be identifiable on the network. And so you probably already know about these IP addresses, and these are actually changing a little bit. We're going to talk about that here in just a second, and I will see if I can pull up an example of this. Yeah, because it doesn't talk about IPv6. So we're talking about IP addresses. So there are 4 different octets. Each can go up to, from 0 to 255. There are a few private IP ranges. I wonder if so yeah, this is one of them, is the 192.168. And then you have 2 other octets that you can play with to build out that private network. The 10, I believe it's just 10 go. That should be, where the first octet is 10, I believe that is its own private network. And then 172. So here we have, these are the different IP ranges. So we already talked about 192.168. 10.0.0.0 to whatever, you get those last 3 octets, and then we got 172.116, and then you can do 172.131. That gives you a couple octets to play with as well. A little bit more than that, but you get it. And here, this actually shows you how many IP addresses you can play with each IP address range. The 10, as you can tell, the 10.x gives you way more IP addresses, over 16 million. I mean, almost 17 million IP addresses. And so that's, if you're wanting to build a huge private network, using the 10 IP range is pretty good. So you're probably already familiar with IPv4. That's really what we've been playing with. That's where you have those 4 different octets. However, a problem kind of started to appear where you have a growing proliferation of devices on the internet, but you only have so many IPs that you can really play with, right? And so you need a new method for creating IP addresses to continue to assign to new devices that basically ups the limit of the amount of devices that you can have on the internet. And so we're going to talk about this picture right over here on the side. This is from Comparitech. So credit to them for this graphic. So here on the right side, you can see IPv4, and you see kind of what that looks like. Again, it looks a lot like what we were talking about, and the range is 4.3 billion possible addresses. Now that might sound like a lot, but there's 7 billion or over 7 billion people on the planet. Does everybody have a device? I mean, that's a great question. I'm not exactly sure, but most of them probably have some kind of a cell phone, some sort of a mobile device, which might require, it probably requires an IP address. Then you have all kinds of other devices that businesses have that need to be public facing. And so that number is really very small. IPv6 on the other hand, and you see the kind of the schema for these addresses, it definitely looks a little funky. And it's using hex or hexadecimal to kind of express the address, but it gives you 340 undecillion possible addresses, and I've literally never heard of that number before. So let me real quick pull up a tab on how many zeros undecillion is. Undecillion has 36 zeros. So that's a lot of IP addresses, right? It gives you, as you can imagine, a much wider flexibility on devices that you can be putting onto the internet. So we're actually, no, I lied. They do have it here. I'm a goof. I didn't even see this graphic. So you do see IPv6 here, talked about here, and they're kind of going through really the backstory of what's going on. So yeah, they talked about it. 340 trillion plus. I mean, unbelievable. A lot of IP space. And you can see this is really like what a full IPv6 address will look like. I mean, as you can imagine, the amount of variance here is 340 trillion plus, right? So that's not the only unique identifier that devices have. They also have a MAC address. And this is what a MAC address looks like. And these can be assigned to actually like the physical device. And these are also expressed in hexadecimal. So you get a lot of obviously uniqueness in these kinds of addresses. So it's split. The first 3 sections are who built the network interface. And then on the right 3, you have the unique address for the network interface. So there is a schema to it. They can be faked or spoofed. Like we already know that IP addresses obviously can be faked or spoofed. MAC addresses can also be faked or spoofed. And this happens, whenever it's basically pretending to use another. I mean, by definition, what spoofing is. So, be careful. What does IP address stand for? Internet Protocol. That's what I thought. Whatever. What each section? Octet. And how many sections and digits do they have? How many sections? 4. Was a MAC media, right? Media access control. Yep. Okay, so let's go ahead and deploy the interactive lab, and let's look through that. Beautiful. So Alice is sending packets through the router to tryhackme.com. Okay, so let's try requesting the site. Bob starts doing the same thing. So Bob's requests are being routed to trash. Why is this? Bob's. Okay, so that must mean that there's some sort of a block on his MAC address. So let's try spoofing Alice's MAC address. 32F 3339. Let's try requesting again, and the requests start going through. So, sometimes you might have some sort of a block going on, and to get by that, if you are spoofing, that might get you past a block. Because again, the router in this case believes that you are Alice. You are not Alice, but the requesting MAC address reflects that of Alice, so it's going to treat you like Alice. That's why it passes it on to tryhackme.com. So ping, and you probably know what ping is, but if you don't, super cool, you're in the right place. It is one of the most fundamental tools available. It literally lets you check if a device is up, like available to the internet and responsive, or if it's down or not responsive. And it'll show you it'll show you how many packets it receives, how many are lost, and how much time it actually takes to respond to that. So what protocol does ping use? ICMP, which ICMP stands for Internet Control Message Protocol. Super easy, super simple. You've probably, again, played with ping, and that's a great way to test if you have connectivity to the internet and you're not sure. Literally ping Google 8.8.8.8, and if it's responding to you, then you are connected to the internet, so good to go. So we'll go ping 10.10.10.10, and then let's go ahead and check the interactive side. It's probably gonna say ping blah, 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 blah. So let's go ping 8.8.8.8, and it's literally, so this is just gonna send like, I believe 4 packets to 8.8.8.8 to Google. 4, yep, there you go. And it'll return a flag for you. So super easy. Ping is very fundamental. You've probably, if you are further along in your cybersecurity journey, you've definitely played with ping at some point. If you've messed around with networking, you've played with ping before probably. But if you haven't, you're in the right place. That is exactly why we're here. So the next thing we're gonna look at is the LAN room. So the intro to LAN includes 5 different tasks. We're gonna learn all about subnetting, ARP, DHCP, and then the OSI model. And we already have actually a video on the OSI model, but it's always good to dive back in because we like review, because we're nerds and we like to learn things. Now, local area network topologies. Over the last 10 years, there's been an experimentation and implementation of various network designs. In reference to networking, when we refer to the term topology, we're actually referring to the designer look of a network at hand. Let's discuss the advantages and disadvantages of these topologies below. So we're actually going to go through, we got a few different topologies here, and each have advantages and disadvantages. The star topology, the main premise is that devices are individually connected via central networking device like a hub. You can see that right here, graphically represented. It's most commonly found because it is reliable and scalable. You can add, depending on, you can just, beef this up and then just keep adding more and more devices. As it, and they mention it here, as it scales, more maintenance is required. And this is kind of like your critical node. If this goes down, all the devices that require it for networking are also basically taken offline. And so this is a critical point of failure that you'll become intimately familiar with. Remember that availability is an entire, part of the CIA triad. So it's not just from a security perspective. It could be from a, disaster recovery perspective. You want to make sure that that is up 24/7, so these devices are good to go, but also that it is secure, which is going to be, it can be a challenge. Bus topology. It relies on a single connection, which is known as the backbone cable. You can see that right here, and each device is hooked up to that backbone cable in some sort of way. Because all the data is destined for each device travels along the same cable, it is very quickly prone to becoming slow, and bottlenecked if devices within the topology are simultaneously requesting data. Now, this can absolutely happen, and it also depends on the strength of this cable, and how much data that it can actually handle at any given time. That's where like a denial of service attack can really come in. You're just like flooding this cable with requests, and some of them are getting dropped or lost, or they're just not making it to these endpoints. There's also little redundancy in place in case of failure. So the disadvantage because of that is a single point of failure along this backbone cable. If the cable were to break, devices can no longer receive or transmit data along the bus. So not fantastic. Sometimes you might, see this, but there are disadvantages to it. And then you got the ring topology, also known as token topology, boasts some similarities. Devices such as computers are connected directly to each other to form a loop, meaning that there's little cabling required and less dependence on dedicated hardware. such as within the star topology. So basically they all kind of form their own network by being directly physically networked to one another. This works by sending data across the loop until it reaches the destined device. There's one direction for the data to travel across this topology. It is fairly easy to troubleshoot if any faults arise. I mean, you'll know if one of these devices go down and requests are no longer being forwarded. So let's say this device goes down, requests will come along the ring to this device, but they're not going to get forwarded. So okay, well, that's what I need to troubleshoot. Less prone to bottlenecks because they're, kind of going around the whole ring, but it is a double-edged sword because it's not an efficient way of data traveling across the network. Again, like for this device to reach this device, it has to go all the way around. So that's kind of a pain in the butt. So what is a switch? A switch is a dedicated device within a network that is designed, It is designed to aggregate multiple other devices such as computers, printers, or any other networking capable devices using Ethernet. These various devices plug into a switch's port. Switches are usually found in larger networks such as businesses, schools, similar sized networks where there are many devices to connect to or on the network. Switches can connect to a large number of devices by having ports of 4, 8, 16, 24, 32, and 64 for devices to plug into. So both switches and routers can be connected to one another. The ability to do this increases the redundancy and reliability, you can read it as, of a network by adding multiple paths for the data to take. If one path goes down, another can be used. Whilst this may reduce the overall performance of a network because packets have to take longer to travel, there is no downtime. A small price to pay for salvation. You're networking Thanos. Snap and the network is down. What is a router? A router's job to connect networks and pass data between them. It does this using routing, hence the name router. Mind-blowing. Routing is the label given to the process of data traveling across networks. Routing involves creating a path between networks so that this data can be successfully delivered. So, pretty easy. Note that routers and switches are not the same. They are not the same. And I believe we'll back up and we'll look at that through the OSI model because there can be some details with the OSI model about switches too. So a little thing to be excited about. So LAN stands for local area network. Routing, that's a verb given for routers to perform. I know. What device is used to centrally connect multiple devices? Switch. Okay, yeah. What topology is cost efficient to set up? Who's the bus, right? Because it's literally bus topology. And it's cost efficient because you have like that central node or that central line and you just need to, hook it up to the line. Is expensive to set up and maintain. Star topology. All right, now let's go ahead and check this lab out. This lab will take you through the flaws of different network topologies in a ring. All devices are connected to, and this is actually, we've talked about this, but this will graphically represent it like I mentioned. So device goes down, cable goes down. No cable. Okay, so let's go and cut it. So as you can see, requests are basically stuck at that machine. Nothing flows anymore. Bus topology, all devices are connected to the single backbone. So there you go. Now it's kind of saying that, again, you can flood this and cause some of those requests to get dropped. So let's go 5. And let's just flood it, right? We're just gonna spam it and cause it to crash. See, we are agents of chaos. All right, so then for a star topology, all the devices are connected to a central switch and every packet is sent to the device that it needs to go. So this is doing a lot of work, but again, let's say, we're an agent of chaos and I just want to hammer that thing. Now the whole network is gone. So each one of these has their pros and cons. We mentioned that the star topology, although it is the most expensive, it's the most scalable. So if you can really, harden this device, and this is what most orgs will do, is they'll just harden the crap out of this device and secure it, then you'll be pretty fine on the network availability. But if anything were to happen to that central node, you're gonna have some issues. So let's talk about subnetting. Who doesn't love subnetting? Let me take a drink. So as you're kind of building this out, you're creating your own network, right? But you're gonna want to go ahead and split these networks into logical segments. So like, let's say you have an accounting network, you have an HR network, you have a finance network, you might have an IT network, you might have a security team, you might have a lab, so you want to have all these logically segmented, not only just so it's less congested traffic wise, but also so let's say an attacker breaches someone in accounting, they're not able to access someone in finance without going through this switch. Where let's say you beef up a lot of the security at this node, you'll be able to catch that kind of movement and lock it down. So whilst you send information in real life to the correct department, networks need to know as well. And this is really where you're going to specify by subnetting. As we recall, an IP address is made up of 4 octets. We did that in the previous room. So if you haven't checked out the networking fundamentals or the what is networking room, definitely check that out, because we do break these down, as well as IPv6 and MAC addresses. So basically they will use the IP address to be able to identify where to go. But these octets will actually identify a network. So you can do, like, let's say 192.168.1, and then the range under 1 is like your accounting, and then 168.2 can be your finance network, and then all those 255 devices are in accounting, or your finance network, blah blah blah. You continue to do that, and then that way packets are routed to the right area and they're not getting sent to the wrong network. So subnetting provides a range of benefits, including efficiency, security, and full control. Absolutely. So what is the technical term for dividing a network into smaller pieces? Subnetting. How many bits are in a subnet mask? What is the range of a section octet of a subnet mask? So let's go 12255. There you go, 0 to 255. What address is used to identify the start of a network? What address? The broadcast? No. Default gateway. That's it. Default gateway. Well, let's talk about the default. No, let's review that, because I got that wrong. Oopsie. It says right here, I'm an idiot. Network address. The address identifies the start of the actual network and is used to identify the network's existence. For example, a device with the IP address range of 192.168.100 will be on the network identified by 10. So that kind of makes sense. So it's basically just the start of the network. Goof address. Yep. What address is used to identify devices within the network? Host address. And you can see that here. This obviously can change. Doesn't have to be 100. It really is just whatever is assigned. And what is the name used to identify a device responsible for sending data to the entire network? Default gateway. And you might recognize these as, well, no, I lied. 255 would be your broadcast address, and that kind of like fires stuff off to the entire thing. But anyway, our protocol. Recalling from our previous task, the device has 2 identifiers, a MAC address and an IP address. Again, check out the What is Networking video. The ARP protocol, or address resolution protocol for short, is the technology that is responsible for allowing devices to identify themselves on a network. Simply, the ARP protocol allows a device to associate its MAC address with an IP address on the network. Each device on the network will keep a log of the MAC address associated with other devices. How does ARP work? Well, you get a request and you get a reply. So pretty simple, right? So when the ARP request is sent, a message is broadcast to every other device found on a network by the device, asking whether or not the device's MAC address matches the requested IP address. If basically like, hey, does this match? And then you'll get a response saying, Yeah, I actually have it as this. If the device does not have the requested IP address, an ARP reply is returned to the initial device to acknowledge this. The initial device will now remember this and store it within its cache in ARP. So address resolution protocol. What category of ARP packet asks a device whether or not it has a specific IP address? ARP something? It was a request. I have like goldfish brain sometimes. Nope. What category of request? Okay. What address is used as a physical identifier for a device on a network? MAC address. And again, if that doesn't make sense, check out the What is Networking video. We talked about that there. What address is used as a logical identifier for a device on a network? IP address. DHCP. So this is the dynamic host configuration protocol. This is basically how, so let me just read this blurb. It would make more sense that way. IP addresses can be assigned either manually by entering them physically onto the device or automatically and most commonly by using a DHCP, and that's dynamic host configuration protocol server. When a device connects to a network, if it has not already been manually assigned an IP address, it sends out a request, a DHCP discover, to see if any DHCP servers are on the network. The DHCP server then replies back with an IP address and device could use an IP address the device could use. The device then sends a reply confirming it wants the offered IP address. And then lastly, the DHCP server sends a reply acknowledging this and acknowledging that this has been completed, and then the device can start using the IP address. So this is literally, you have just joined the network. Hey, it's like, a player joins a football team. Hey, we're going to have you play with this number. Okay, fine. I'll play with that number. That's great. Good to go. So, hey, I'm new here. Can anyone give me an IP address? This is a really good graphic. Hey, sure. Here's the IP address for you. Yeah, perfect. That works for me. I'll start using that. All right, great. See you around. All right. So what type of DHCP packet is used for a device to retrieve? That would be the discover. DHCP type of DHCP packet does a device send once has been offered an IP address? That's going to be the offer. Ooh, nope. Big oof. Send once has been offered. Oh, that's going to be the request. See, I'm reading this a little too fast. Finally, what the last DHCP packet to be sent? That's the ACK, short for acknowledge. So that is the LAN room. And the next thing that we're going to be doing is next will be the OSI model. And what is the OSI model? It stands for Open Systems Interconnection Model. And this text actually here on TryHackMe goes through everything really that you need to know about the OSI model. And it also lists it in order from application all the way down to physical. But we're going to go ahead and read that right now. There are 7 layers. In order from 7 down to 1 is application, presentation, session, transport, network, data link, and physical. And we're going to go through every single layer here in this section. So the answers here, we go with Open Systems Interconnection. There are 7 layers, and the term for whenever information gets added to data is encapsulation. And we will actually be hearing this term quite a bit, especially whenever you get into networking and how data gets added on and how things, how packets get put together. Encapsulation is a term and a practice to kind of get familiar with here. Let's jump to layer 7, application. You should be pretty familiar with the application layer of the OSI model because that's the layer that you interface with the most. Even if you're not in tech or you work in cybersecurity, the end user interacts with this layer the most. Anything with a GUI is operating at the application layer. So of course the answers here are pretty elementary, so you shouldn't really have a hard time putting these in. The answers are also in the text above. The next layer, layer 6, presentation. As the text here says, this is when the standardization starts to take place. At this layer, data is translated to a presentable and consumable form for human people. And so that's actually where we get the answer to the second question on this section. The presentation layer acts as a translator. It also notes that security features such as data encryption, think of HTTPS being the more secure and encrypted form of HTTP, that occurs at this layer. Let's jump one layer down to layer 5, session. This occurs whenever two computers or machines on the internet or any kind of network are able to establish a connection. You establish a session, and within a session, those machines transfer packets between one another, and that is how they communicate with one another. We're going to talk a little bit more about packets here in a moment, but that is basically just a chunk of data between two systems that is transferred within a session. We'll go an extra layer down to layer 4, transport. And this is kind of where things start to get pretty interesting. We're introduced to TCP and UDP. And this is actually something that we're gonna talk about later on in this walkthrough session. We're gonna talk about this later on because there's actually an entire room dedicated to TCP and UDP. But at this moment right now, let's be familiar with what TCP and UDP are. TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. And these are two methods that data is transferred between two systems over the course of a session. Now, there are two different kinds of methods because TCP is more secure and better for downloading and, kind of better communications and stuff like that. It's way more reliable, and we'll talk about why that is in the next video. But UDP is kind of like it's a one direction thing. Computer A is sending data to computer B, and it doesn't stop to confirm whether or not that data actually arrived to computer B. It just continues to send data. So we have a couple graphics here on this walkthrough, and we see basically the packets are different segments of a specific file. So in this case, the file would be a picture of this adorable puppy, and it is broken into 3 packets, basically containing different segments of the final product, right? And so over TCP, the web server is going to confirm with the computer that it received each packet, so that way the final product is complete. However, with UDP, the web server doesn't care. It is just going to spit out those packets, and hopefully those packets will arrive. Well, as you can see in this example, packet 2 unfortunately was dropped en route, and so the final product was this sad, derpy looking puppy. Still adorable, still fuzzy, but very much incomplete. So running through some of these answers, we'll see that UDP simply doesn't care if data is received. And so TCP would be used for something like an email client, because obviously you want to make sure that the email makes it to the recipient. However, for something like video streaming, like you watching this right now, it doesn't, this is actually happening over UDP. It's not that YouTube doesn't really care that chunks of this video might get dropped en route to your device. It's that it needs to be able to send this information fast enough that you can actually receive this video in a high enough video quality. If it's getting to a point where some of those packets are getting dropped, then it'll actually lower the video quality. That's why sometimes you might be watching a video in HD and then it might drop to like 720p. That's because some of the packets it might be noticing is getting lost, and so it will lower the actual size of the packet so that way it can continue to do that. But say you were to download this video, you need a completed video to be downloaded. That would happen over TCP because obviously YouTube wants to make sure that the video you are downloaded is complete and whole and is of the quality that you would like. Now let's jump down to layer 3. All of this happens in a network. We do assume. And this is the layer in which you find IP addresses. And each computer might have a different preference on how they reach each other. Some computers might preference a shorter path and some might prefer a more reliable path. And those may not always be the same. But ultimately, they will find each other using an IP address. Jumping down to layer 2, we get to data link. And this is actually where we come up with MAC addresses. Every single device has a MAC address. Unlike the IP address, the MAC address cannot be changed. It is burnt into the networking card of your device. So I hope you like it. There's no removing it. It is with you. And now finally, layer 1, physical. And we are introduced to Ethernet cords. And this is actually something that you might be familiar with. You might have one plugged into your computer right now. But this is like the physical connection. So think of fiber optic cables and things like that. The physical method or the physical medium in which data is transferred. Now, at the end of the walkthrough, you get to play through a game and you get a cool little flag. And basically, to win the game, you have to guess the correct order of the OSI model. It's not too hard, but the flag, I'll let you get for yourselves. So in the last video, we were going through the OSI model, and we were actually introduced to packets using this graphic that we're looking at right now with the cute puppy. The final file is the full picture of this adorable puppy. However, it was divided in transport into little packets. packets, and each packet, as you can see, covered a segment of that picture. There's a table here I think that is important to zero in on, especially while you're doing this walkthrough. It includes a header and a description of the header that you will find on packets. Here you have time to live, which sets an expiry timer for the packet in case it doesn't make it to the destination. It includes a checksum, which provides a level of integrity for the packet. It also includes a source address, so that way the destination knows where this packet is coming from. And it also includes a destination address, so that way it knows where it's going to. Now, a difference between packets and frames. A packet contains IP address sourcing information, so it knows the destination and it knows its source. A frame, however, doesn't have that information. In the last video, we were also introduced to TCP and UDP, and as a quick review, TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. So we've talked a little bit about what TCP is, but how exactly does it work? Well, TCP is a protocol that you would want to use. It basically ensures that data will make it to its host. This, however, does make the flow of information slightly slower because with every packet being sent, there is a confirmation that it has been received. One thing that you should be familiar with, though, of course, to be able to catch whenever this is happening live on your network, whenever you're running something called Wireshark or like Wireshark, is the TCP three-way handshake. This is basically how two machines are able to initiate a conversation between one another. And we see here we have the graphic that shows the TCP handshake between Alice and Bob. Alice initiates the conversation by saying SYN, or by sending a SYN packet. And then Bob responds by saying SYN ACK, basically acknowledging the SYN packet that Alice sent. And then Alice acknowledges that and fires an ACK packet back. So altogether, we have three different things that occur. It is a three-way handshake. After that, they're able to share whatever data they need to, and then have the conversation that they need to have, and then they close that conversation. That conversation is closed whenever Alice or Bob sends a FIN packet, and then Bob acknowledges the FIN packet and then sends a separate FIN response, and then Alice acknowledges Bob's FIN. And then at that point, the conversation is over. Pretty simple, right? Well, you can actually practice this in TryHackMe. This includes a flag, and I'll let you go ahead and find it for yourself. But now let's go on to User Datagram Protocol, or UDP. Unlike TCP, UDP doesn't care. UDP lives its life. UDP sends all kinds of information regardless of whether or not it is received. A term to keep note of is stateful and stateless. TCP is stateful because it maintains the integrity of the session and it tracks that everything is being received. UDP, however, is stateless. It doesn't track that. It literally just spurts out information. Because it just kind of sends information, it's much faster. However, that might lead to unreliable data reception. In this graphic, you can see that Bob sends a request to Alice for information, and then Alice sends the response directly to Bob. Alice doesn't exactly check to see that Bob received any of those responses. They're just gonna be there. To wrap up this room, we are introduced to ports. Now, what exactly are ports? We know IP addresses from the last room in the networking layer. And basically, an IP address is a unique networking address that each computer has. The device that you're watching this video on right now has an IP address. But how exactly does your device know which data is supposed to go where, which program it's supposed to be received from, what kind of data it's being received? After all, it doesn't just open up a giant collection bucket and just received all data as one, kind of thing. It actually organizes the data by what's called ports. And there are actually very common ports, and there's a table here showing some of those right now. For instance, there are 65,535 ports on your device right now. Not all of those are open, but there are several common ones that you should be aware of. For instance, port 21 is for file transfer protocol, commonly used to share files between two devices. Port 22 is a common one that you might already be familiar with, and that's for secure shells. Port 80 and port 443, that's actually how you browse the internet. Hopefully you're not using port 80 so much because that is the unencrypted, that is just HTTP. HTTPS, however, is done on port 443, and that is more secure. You're probably watching this over port 443. There are several other ports that you should be aware of, but port 80 and port 443, if you're just kind of like, if you're the end user, Those are probably the most common ports that you use on your device. There is a practical on here that also includes another flag. I'll let you catch that as well. Now, first we're going to talk about the introduction to port forwarding. This is an essential component to being able to move data securely from an internal network to the internet. Now, before we get too into the weeds here, we need to be familiar with something. We already know about IP addresses. We talked about that in the OSI model video, and we already talked about in the last video talking about packets and frames and that kind of. However, there are specific ranges of IP addresses that are known as private IP addresses. For instance, 192.168 is known as a private IP address range. And that basically allows for you to create a large and scalable internal home network. You can literally have anything from like 5 devices on your internal home network to thousands of devices on your internal home network, depending on how you network it. However, those devices likely need to communicate to the internet somehow. After all, you're watching this video, right? And unless you're watching this from YouTube corporate, in which case, howdy, how's it going? Great to meet you. Then you're definitely not able to get this video feed from your internal network. And that is how port forwarding enters into the conversation. Your router has an internal and an external IP address. And the internal IP address will be a private IP address, like a 192.168 kind of IP. And then its external IP address will be unique to it, and it'll let the internet know what address to be able to route the request from your device back to you. But we also talked about ports, and say you're watching this on port 80 because you enjoy having no encryption. You live wild. Then you will send that request to port 80 of your router, but it will also translate that to port 80 for the external side, and then it will forward it off to the internet. You can configure this, so say you don't want port 80 open to the internet because everybody in the world knows that port 80 is unencrypted HTTP, and they want access to that. So say to add a little bit of ambiguity to the ports, you want to use, say, port, 33333. You can open up port 33333 on your router and then say, okay, whenever I send a request to port 80 on the internal side of your router, I want you to send that through port 33333 on the external side. That's how you can do port forwarding. Now, that doesn't necessarily mean you're like 100% secure. If an attacker scans your device and they scan all the ports and they see that port 80 is closed, but they see that HTTP is still open on port 33333, well, then they still see it. However, if they're not scanning for all ports, they're only scanning for the well-known ports, and they see that port 80 is not open, then maybe they'll move on. But there's a number of other functions that port forwarding is totally good for, so definitely look into that if that's something you're interested in. Next, let's talk about firewalls. This is very important. A firewall is basically responsible for protecting your network, and you can set up a number of rules with a firewall. For instance, if there is a known hostile IP address on the internet that you're familiar with, you can tell the firewall to drop all packets coming into your network from that IP address. It will also inspect the packet and look for signatures of maliciousness. Now, a very important fact to know about firewalls is there are 2 kinds. There are stateful and there are stateless firewalls. A stateful firewall looks at all packets and the context between them, but a stateless firewall only looks at each individual packet. There's all kinds of information to be gained in either case. An individual packet in and of itself might contain an amount of maliciousness. However, one packet on its own may not be malicious. However, a number of packets put together might be malicious. So there's definitely pros and cons in either case. These also operate at different levels of the OSI model, layer 3 and layer 4. This practical includes a flag, so I'll let you work through it, but this is a great visual representation of how creating a firewall rule can stop, in this case, a denial of service attack, where an attacker is trying to overwhelm an internal server with tons of pointless requests. Now let's talk about virtual private networks. This is another thing that we've talked about on this channel long ago. You can check that out if that's something that's interesting to you. However, let's talk about it right now as well. Say you have 2 networks and you're in network A and you want to get access to network B. We'll say network B is a business and network A is your home. You can use a VPN to be able to authenticate into network B over the internet in a secure tunnel, and that will allow you access to internal resources on network B. This is a technology that has allowed for work from home. So all through the pandemic, people were able to utilize VPNs to be able to get the job done. This is also something that people use to be able to access systems in other countries, and that allows them to have a layer of anonymity with their network traffic. It's not perfect, but it definitely can help. Say you're in a country like China and you don't have access to a resource like Twitter or YouTube, and you wouldn't be able to watch this video, which makes me very sad. You can use a VPN and access YouTube and then watch this video, and we can be friends. 大家好，我是 StudioSec. So here we're introduced to three different VPN technologies: PPP, PPTP, and IPsec. I'll let you go through this table and take some time to study it, but it's definitely something that is important to know later on. Now let's talk about LANs, and this is actually something that we've talked a lot about already in a previous walkthrough from this actual series, and you can check that out. But here's kind of a nice little refresher. We're talking about routers and switches and how switches can provide some scalability on your network. An important thing to know is that there are two different kinds of switches. One switch can operate at layer 2 while another can operate at layer 3. Layer 2 switches will forward frames, but layer 3 switches will do that and they will use IP addresses, meaning that a layer 3 switch can actually really help scale up your network. As you can see on this graphic, this switch is actually creating two separate internal virtual local area networks: 196.168.1.1 and then 192.168.2.1. These are two separate internal networks that this switch is able to route between. Now, although I use that term route, it is not a router, so definitely do not get a switch and a router confused. Now, to wrap this room up, we have another practical exercise that you can check out. Again, another flag. I'll let you go ahead and do this on your own, so that way you get the practice. So that has been the networking fundamentals room in the intro to cybersecurity room on TryHackMe. The next thing that we're going to be doing is the DNS in detail. And if we're going to be going over the what is DNS, this is a section in the how the web works section of the pre-security path on TryHackMe. So what the heck is a DNS, and why is it that every time something goes offline like Facebook or Twitter, everyone says that it's the DNS's fault? Well, the DNS stands for domain name system. Think of it as a computer that stores name. Think of it as the internet's address book. It literally will point an IP address to a domain name. So let's take an arbitrary IP address of 111.111.111.111, whatever that's going to be, and let's say that that is abc.com. Well, instead of going to your web browser and typing in 111.111.111.111, you're going to type in abc.com, because the DNS is what is going to know that abc.com is 111.111.111.111. Why did I make that my example IP address? I could have literally just used 11. So that is what this section is going over, is what is DNS. And here, of course, this graphic shows an example IP address for tryhackme.com. So that's simple enough, right? Well, there are also more levels of DNS, believe it or not. In the next section, we go through the domain hierarchy and we see root domain, top level domains, and second level domains. And it will show examples of what each one of these domains are. For instance, you can see .com is like a normal privately owned company, and .gov as any site that belongs to the US government. Other governments have websites on the internet. For instance, .ru belongs to Russia. .cn belongs to China. There's several others. There's a whole directory I'm sure you can find online, so check it out. So the top level domain will basically signify whether or not it is an enterprise or a government or an academic institution. Your second level domain will actually show the name of the organization itself. So for this example, we're looking at TryHackMe. So TryHackMe and TryHackMe.com would be the second level domain. And then for subdomains, we look at basically sites that exist within a specific domain. So for the example given here is admin.tryhackme.com, and that could be like an admin portal. Another could be shop.tryhackme.com. That could be a storefront. The more domains that you see on your browser, the more you'll start to recognize these pieces and kind of how many sites have individual subdomains that exist under the actual second level domain. DNSs collect records, and these are organized into several different kinds of records. For instance, an A record resolves the IP version 4 address. So you're probably more familiar with A record. A quadruple A or AAA record, I don't know if that's how you're supposed to say it. That record resolves for IPv6 domains. So that's probably something that we're all going to be seeing a lot more here in the very near future. CNAME records resolve to another domain name. So for instance, let's say TryHackMe.com would like to redirect to store.tryhackme.com or shops.tryhackme.com. That would use a CNAME record. MX records, mail exchange records, basically are for emails, and TXT or text records are basically for free text field. Now, finally, on this walkthrough, that takes us to making a request, and it shows you basically the steps of making a request, the different types of DNSs that you'll be in contact with. So first, you're going to try to see if you have any caches on your computer. So let's say whenever you're going to google.com, you'll type google.com into your browser, and then your computer will check and see if it has any cache, if it has any cache records to show the destination for google.com. If it doesn't, then it will forward to a recursive DNS. That's usually provided by your ISP. This also has a cache of locally stored and recently searched domain names, so it will check there as well. If that doesn't work, it will forward you on to a root DNS, and these are the backbone of the internet. That will refer you to the top level domain name, and then from there you'll be forwarded to the authoritative DNS server, which will actually return you google.com. So finally, to finish this walkthrough, I will leave the practical to you. There is a flag that you can get, and that is some good practice, and it basically will show you what all is going on with DNSs. But that is DNSs in detail. Very exciting. Pass. So what is HTTP? There is a 90% chance, that is a fake statistic, that you watching this video right now know exactly what HTTP is. But in case you have never interacted with the internet yet, there is a percentage chance that that has happened. HTTP stands for Hypertext Transfer Protocol. Now, you want to be familiar with two different types of HTTP. There is HTTP, which is just that, it runs on port 80, and then there's HTTPS, which is HTTP, but the S stands for secure, and it is the encrypted, more secure version of HTTP, and that runs on port 443. Now, there are several practical labs here along this walkthrough. You can do that on your own to be able to grab the flag for yourself. It is great practice and great visual representation of what's going on. But right now, let's jump into what exactly a URL is, which stands for Uniform Resource Locator. And here you have a nice graphic that breaks down URLs in depth. For instance, you have a scheme, you have the user, the host domain, the port, path, the query string, fragment. If you're brand new, this might seem a little overwhelming, but don't worry, it's fine. We're gonna look at this. Basically, the scheme shows the kind of protocol you're gonna use. So for instance, it could be HTTP, it could be HTTPS. You could use FTP for file transfer protocol. There's several other methods that you can use as well. The user, I feel like I haven't really seen this very often, seeing the username and password shown right there in the URL. So I think that this is kind of an older scheme. Maybe I'm wrong, let me know in the comments, but it could be theoretically in the name, and it would be username, password at, and then the actual domain itself, tryhackme.com. Now you'll see a colon and a port, and that is basically specifying to the destination that you are wanting to access via the specified port. So because we are using the scheme of HTTP, its default port is running on port 80. So logically, we will be reaching out to port 80. Now, a path, we are trying to go to the path of view room. So we are looking for a room with an ID of 1. And that includes a fragment of task 3. So whenever you make a request using HTTP, basically you will specify your method, and that could be get or post. There's several other methods. We'll talk about all of that here in just a moment. Slash for the page, and then you'll do slash if you're doing the root page, or you can actually specify the page itself that you want to grab or whatever. Do any kind of request to. Then you will specify your HTTP protocol version. And then here we have down below an example of an HTTP request. You can catch all of this even in Burp Suite. If you are intercepting, or even if you're just passively watching web requests being performed, you can actually view all of this being done in Burp Suite. In fact, if you are intercepting HTTP records, then that traffic will be unencrypted. So not only can you view the traffic happening in Burp Suite, you can actually make different changes to it, and that can actually impact the user or the website, because now you are manipulating communication. That is called a man-in-the-middle attack. It's illegal if you don't have permission, so get permission or do it in home lab to yourself. Now, we were just talking about the different types of HTTP methods. So like, what are we talking about here? Well, these are just 4. There are several others out there, but the main ones that you want to be familiar with are get and post requests. Get requests basically are saying, hey server, get me this, and then post requests are saying, hey, I'm posting
posting this to you. A put request updates information, and a delete request deletes information. But either one of those, you may see those much less often than you see get and post requests. Now on to the fun conversation of HTTP status codes. Who loves these? These are the best. Well, here we have a lot of the standard status codes, including we have basically the ranges. So 100 to 199 is informational or response. 200 to 299, it means it's some form of a success. For instance, 200 is okay. 300 to 399 is for redirection. 400 to 499 is client errors, and 500 to 599 is server errors. And if you're not familiar with what that means, you basically consider yourself to be the client and the server that you are connecting to be the server. So 400 is basically the web server saying, hey, it's your fault. 500 is saying, hey, it's my fault. And then of course, below that, we have the common HTTP status code. You'll probably encounter these at some point. In fact, error 404, page not found, that's it's gotta be a meme on the internet at some point. So these will be good to be able to familiarize yourself with. However, I feel like, at least in my experience, whenever I see one of these codes, it will blast the message. So you won't just get 401. You might in some cases get that. You might have to do some Googling if you forgot, but it might also just say 401 not authorized right below that. So either way, keep these in mind. Now let's go to HTTP headers, because this is just so much fun. These are basically sent from the client, basically you, to the server. They'll basically show the host, so basically who you are. They will show the user agent, so basically your browser, the content length, so you know how much data that you are expecting, and accept encoding, whether or not you want to, you know, accept encoding, and a cookie. We will talk about that in the next section, so keep that in mind. Common response headers, set cookie, so that will actually set the cookie for you if that hasn't been set yet. Cache control, which will store the content. Content type will tell you, well, basically, you know, are you looking at HTML, CSS, a combination of these, and then content encoding. So those are some things to keep in mind. Now, mind you, all this is being done automatically on the back end. You're not manually doing this. Obviously, your browser and your computer are doing that with the server, but it's helpful, especially if you're wanting to get into cybersecurity or networking or what have you, to know about these things. Now, what are cookies? Nom nom nom. Cookies basically are unique to your session. They may include authentication data, so if you log into a service online, then your unique ID might be stored in some sort of an obfuscated form, hopefully in the cookie itself, and that basically lets the server know that you are you and you are coming from a specific session and you are authenticated. Your cookie will be unique to you and stored. So let's say you log into a website, then you leave, and then you come back the next day, you'll have the cookie and you'll be able to show the website, hey, it's me again, Hank the Cow Dog. And then you'll be able to continue to do whatever you're doing and it will remember you. Why does this matter? Because attackers might try to steal your cookies. No, not my cookies. And they will try to use that to imitate basically you to the web server and perform tasks as if they were you and steal data potentially. So protect your cookies with your life. If you want proof that you have cookies, check your browser. It has them somewhere. Now, to finish this room up, there's a making a request practical. There's several flags on here for you to get. Go ahead and jump through it. Super duper easy. You're gonna have a blast. It's just basically running through the different types of requests you can make to a web server. So with that, the next room will be how websites work. So how do websites work? Basically, you will make a request from your browser. That request will travel through the internet and it will hit the web server. The web server will respond to your request and deliver it to your browser and present it to you in a nice, neat fashion. For instance, whenever you decided to watch this video, your phone or browser, wherever you're watching this from, made a request across the internet to YouTube saying, hey, I want to watch this video, give it to me. And then it said, okay, bet, I'm going to start streaming this video to you, so get ready for that. And then it started to do that, and well, here we go. Now there are two sides that we need to remember in this conversation, the client side and the server side. Consider yourself the client side. You are the client and the server is what's handling you. And the server is basically what has the website. They are providing the website and its contents to you. So how does it actually give this website to you? Well, the website is coded using HTML or hypertext markup language. It's really not hard to use HTML. I mean, you can see kind of an example down here. It's basically using logical sections and segments to create a web page. You can also use CSS and JavaScript to add functionality and neatness to the website. Pretty much every single website on the internet is a combination of these elements. So would it be helpful for you to know about how to use HTML, at least how to be able to read it? Yeah, that's not bad. And it's super easy, don't worry. If you'd like to see more, let me know in the comments. Same with CSS and JavaScript, because then you can actually manipulate with some of the functionality or some of the graphics. But you know, more on that at some point, I'm sure. Now a disclaimer, for pretty much every section on this walkthrough, there are some practical segments. So I encourage you to walk through this on your own and do some of those practical segments. I obviously have done them in a footage of that, but I just think that it's great practice for you to do that, especially on the sections where there are flags that are unique. You should definitely be doing that. Now let's talk about JavaScript. This is one of the most popular coding languages in the world, even though I hate JavaScript. This is basically used to control the functionality of the pages. For instance, if you're familiar with cross-site scripting, that's a type of attack that you can do on web pages. You're basically exploiting a logic flaw in JavaScript that the designers of the web page didn't account for. So like HTML, it is very helpful to be familiar with JavaScript and kind of how to recognize those things, especially whenever you're looking at the page source to see if you can break something. On the next section, we're looking at sensitive data exposure, and you can actually see that an example of sensitive data exposure, which is part of the OWASP top 10, there will be a video on that coming out at some point, but that's a big no-no. You definitely don't want to have sensitive information, sensitive personal identifiable information, any kind of details about your infrastructure. You don't want that hard-coded on your website. If you really need it on the web page, then you should retrieve it and not really show it anywhere in the hard code or in the code itself on the page source. Funny story, very true, very real from this last year. In the state of Missouri, a reporter actually noticed that there were sensitive information from teachers, including social security numbers, hard-coded like this and exposed on a website. They decided to report this to the school, and that allowed the school to be able to take that information down. However, the state government decided that made that reporter a hacker. Even though they were taking the responsible step of notifying the school, hey, I noticed this, you need to take this down, this is very bad. And they did so, and it really helped, protect from a pretty bad goof up when building the web page. Now that reporter is getting punished. So definitely whenever you're putting these sites together, be very, very careful. The final section is on HTML injection. Basically, that's whenever you are inputting a malicious string into an input field, and it is either putting up some sort of malicious link on the site, it is rerouting the user to somewhere else. There are a number of things that you can do with this, but this includes a practical that you should definitely do. It's pretty fun. So the next section, we're going to put it all together. Now we've learned quite a lot about how the web works. We've learned about DNS servers, we've learned about HTTP, we've learned about HTML and JavaScript and all those things. So let's actually piece it all together and see how it all works in a nice synchronous fashion to be able to bring you this video. As you can see in this graphic, you make a request in your browser, that hits a DNS server. That DNS server will basically point to the web server that you want to connect to, and then the web server will respond and give you the content that you are requesting. There are several other components that go into this entire infrastructure, including load balancers. Now, YouTube doesn't just have one web server. That would be insane. YouTube had more likely, and this is probably the same with most companies that host anything, is they run with a series of load balancers, because the more requests that a web server gets, the more overwhelmed it becomes. And so you need load balancers to be able to help with that situation. Imagine you are self-employed and your company is expanding. There's only so much work that you individually can handle. So eventually, as your company grows, you hire somebody. Consider this similar to kind of how a load balancer works. As one server starts to get a little overwhelmed, some of that work gets pushed over to one of the load balancers, and it helps kind of keep everything nice and even and keeps the flow of traffic nice and smooth. Next, you'll have a content delivery network. And this is pure speculation, but this might be part of how YouTube works because it hosts all kinds of content like videos like this one. So whenever you want to watch this video, you'll ask YouTube, hey, I want to watch this video. And it will determine which server is closest to you that stores this video. It will route you to that server, and then that server will provide you the content. That way, that reduces the latency between the server and you. Next, you'll have databases, and these are basically storing massive amounts of information. I'm sure you know what databases are. are, but that's pretty much it. And then you'll also have web application firewalls, which add a layer of protection for the infrastructure as it is dealing heavily with the internet. You want to be able to filter a lot of that and prevent a lot of denial of service attacks and a lot of the malicious IPs that you see out there. So on this last section, we're looking at how web servers work. And if you've been watching along this series, then you probably know all about web servers because we've been talking about them the past several episodes. However, if you haven't seen those yet, definitely check them out. But what are the web servers? They are literally the server that is responding to your requests and getting you the information that you require. Some web servers run on what's called virtual hosts, and I've already have a video about virtualization. You can check it out right there. But I mean, it's a web server that is virtual. A lot of web servers run on containers. What's that? Check out containerization. There's links to those videos down in the description as well. You'll also have static and dynamic content. For instance, let's say you pull up a blog post. There's no videos, no graphics, nothing. It's literally just a document. That is static content. Nothing's changing. It's literally just the document. So you'll read the blog post and then that's it. But let's say this video. There's a lot going on. I mean, I'm moving around, I'm making noise. It's crazy up in here. This would be dynamic content. The web server will handle these kinds of content differently. Now, finally, there are scripting and backend languages like HTML, CSS, JavaScript. We've talked about those as well already. So finally, at the end, there's a practical exercise that includes a flag. You should definitely check this out and give it a shot. Grab the flag, and then let me know down in the comments section if you had a lot of fun.
We're finishing up the TryHackMe Pre-Security path by walking through Windows. This is a three-part series, and by the end of this, we should have a strong grasp of Windows. So let's dive right on it. First, as a precursor, you can walk through this on your own on TryHackMe. I highly encourage you to do so. There are some interactive labs and challenges that you can do, and it also gamifies the learning and gives you something a bit more applicable to do as you're watching this video. Now, what is Windows? You're probably very familiar with what Windows is. In fact, you're probably watching this video right now on a Windows computer if you're not watching it on your phone. Windows is the most used operating system in the world, and it's gone through so many iterations, and it's been around for decades. And so, as you can probably imagine, in the security world, it's notorious for vulnerabilities, but that's not necessarily Windows' fault. It's really just a symptom of how widespread its use is and how much attention attackers give to it simply because of its widespread use. That's basically to say that if Windows or Mac OS was the most used operating system in the world, then those would probably be flush with vulnerabilities as well that we know of. Now, the most recent version of Windows is actually Windows 11, and it mentions here that Windows 11 is current and live, but Windows 10 is probably going to be the most widely used at-home operating system. Sometimes you'll come across Windows 8, and other times you might even come across Windows 7 or Windows XP. In fact, it's not even unheard of for Windows Vista, even when this is filmed in 2022, to still be used. So it's frightening. Now, real quick, let's walk through the GUI, and you're probably familiar with the GUI, so we're just gonna fly through it. But the main things to keep in mind are, of course, the desktop, the start menu, the search box, the task view, taskbar, toolbars, and the notification area. Again, you're probably already very familiar with what these are, but you can actually personalize your desktop using the settings. The start menu is where you're gonna find pretty much anything that's on your machine. And actually from the start menu, you can use the search bar, and that allows you to basically search your computer. And if it isn't already installed, then it'll actually search the internet for something specific. If you have a favorite app, you can pin it to the taskbar. That's a nice way to kind of shortcut access to different applications that you like. And then of course you'll have the notification area, which will tell you very important messages that you need to know. Now let's talk about the Windows file system, or the new technology file system. As it says on TryHackMe, NTFS is known as a journaling file system. In case of failure, the file system can automatically repair the folders or files on a disk using the information in log files. This also allows for files larger than 4 gigabytes. Imagine not being able to store a file larger than 4 gigabytes. That would be so frustrating. You can also set specific permissions per folder or file, which is great. You can also compress folders and files, which really helps for storage efficiency. And then of course, you can encrypt your files. There's a number of permissions that you can set on a folder or file basis, including read, write, read and execute, list folder contents, modify, and full control. And these are different permissions that you can set on a user by user basis. So say you have a number of users on a specific Windows machine, and you you want some to be able to read, some to be able to write, some to be able to modify, etc. You know, these are things that you can do to be able to have some good identity and access management. And you can do all these on the Properties tab on each file or folder. Now let's talk about Windows System 32. And these are going to be very, very important because this is where your operating system is loaded from. These will include information on all kinds of environment variables that you'll need to be able to use for your operating system and more. So obviously you want to make sure that this is backed up somewhere in case something in here were to be corrupted. Your operating system would probably have a hard time loading. So if you can have your operating system stored on a thumb drive that you can boot from or a disk that you can recover from, that really wouldn't be a bad idea. Long story short, don't do anything with System 32. Just don't touch it. It is very important, and you know, you don't want to break anything in there, because if you do, yeah, your computer might be broken. Now let's talk about user accounts, profiles, and permissions. And this is where things can get pretty customizable on a per machine basis. Here you can basically create new accounts for new users that will want access to this specific machine, and you can modify their permission set. So maybe you don't want them to have access to every single application, or you want them to have limited access to different applications and folders and files. This is where you can do that. And you can do all of this in the settings tab, where you add a user and then you basically you specify what kind of user you want them to be, and you allow your computer some time to be able to build that account. If you're running this on a network and maybe you're inside of an Active Directory, this is all stuff that you can tie into Active Directory as well. Another important principle is user account control, and this basically allows a user to run important and admin and administrator tasks without having to be logged in as the administrator. And this basically prevents you from really badly breaking anything on your machine, and also giving users too much control on a system. And again, these are all things that you can configure within the settings or the properties tab of a specific user. Next, let's talk about the control panel, because this gives you a lot of flexibility and control over your system, the different devices that your system is using. Really, you want to be pretty familiar with your control panel, especially if you're wanting to like plug something in, or you have a driver issue, something like that. We'll kind of break down some of the options that you have within the control panel. You have system and security, network and internet, hardware, programs, user accounts, appearance and personalization, clock and region, and ease of access. And as you can see, within this, there are so many different controls that you have at your disposal, and this really allows you to customize your experience within Windows. Pretty much, if you have any kinds of issues, from networking to different devices not working to the time, that you can really modify things within the control panel to try to troubleshoot and get things working again. And finally, that takes us to Task Manager, and this is going to be a great place to be able to identify where your CPU is being utilized and give you the flexibility to kill processes that are taking up too much CPU that you aren't actually using. So if you notice different processes running here in Task Manager that you think might actually even be malicious, then that's something that you can also drill down into. Note that you'll have processes running in the foreground and the background. Basically, that means that if it's in the foreground, then it might be something that you're interacting with, and if it's in the background, then it's something that the CPU is running, but you're not really having to do anything to keep it going. So with that, we're going to jump into phase 2 of Windows. Now let's talk about system configuration, and this is where you can get a lot of customization options on your experience within Windows. But this also gives you a lot of options when trying to troubleshoot startup problems. So if you go down to your taskbar and you type in msconfig, you'll have the option for system configuration, and you can kind of look through here to kind of see what is going on. But there are 5 tabs that you can use to investigate: General, Boot, Services, Startup, and Tools. In the General tab, we'll see some of the more general settings for your machine's boot up process. In Boot, we will actually see where it is booting up from. So by default, it should be /Windows in the C drive. In the Services tab, you'll see a lot of the services that run in the background and their state. In the Startup tab, you may or may not see anything. So, I mean, definitely check it out on your own system and see if you see anything interesting. They note on the VM that you won't see anything interesting, and they show a screenshot, which, I mean, doesn't really show anything either. And then of course in the Tools tab, you have different kinds of tools that you can use on your system. Now in the last video, we talked about user account control, and you can actually set some of the actual user account control settings to actually have different experiences and different security settings and so forth with every different user. They do note, don't turn these settings off
definitely don't. But here they show a picture of the slider that pops up, and that basically will dictate when you are notified or how often you're notified when programs or applications are changed. Next, let's go to computer management. And this is actually another very important place to remember while you're on Windows, because there's a lot of settings and customization tools here that really you want to be able to be aware of and use. For instance, you'll have system tools, you'll have storage, and then you'll have service and applications. And inside of each one of those categories, you have a bevy of other kinds of options. So within system tools, you can see you have task manager, event viewer, and some more options. In storage, you have disk management. That's where you can partition parts of your disk if you'd like different partitions. It's really there's a lot of options at your disposal to make changes to your Windows machine. One of the important ones that you want to know about is event viewer, and that basically allows you to view some of the events that are going on your machine. Sounds pretty straightforward. There are also options to check out some of the logs on your machine. You can also check out some of the shared folders. There's also a performance monitor that you can check to make sure everything's running efficiently. So that's pretty cool. And then of course you have the device manager, which will show your device and then any kinds of other devices. Maybe you have like a keyboard or a monitor or something like that attached to your machine. And this is where you can kind of check those out and make sure that everything is working properly. Sometimes you might have an issue where a Bluetooth device isn't working, or for instance, if you're gaming and you have a game controller and it's not working properly, you might want to check the device monitor and check some of the settings. Maybe there's a driver that might be disabled. That's a common issue there. Under the storage settings, you can see some of the different disk management options. And here, of course, you can partition different parts of your disk. If say you want to have a separate partition specifically for something, this is where you can do that. There's a ton of other settings. So, just kind of look around in here, make sure that you don't make any changes unless you know exactly what you're trying to accomplish. You don't want to break anything. That would be very, very bad. Next, let's talk about system information. And this is per Microsoft. Windows includes a tool called Microsoft System Information. You can find this with msinfo32.exe. This tool gathers information about your computer and displays a comprehensive view of your hardware, system components, and software environment, which you can use to diagnose computer issues. That's a pretty powerful tool that you can definitely use while troubleshooting. Say there's a problem, this might be a good option to check out. And of course, you have the system summary, hardware resources, components, and software environment, each with their own options that you can use to be able to diagnose things. One of the other important things to keep in mind is something called environment variables, and this is from Microsoft. Environment variables store information about the operating system environment. This information includes details such as the operating system path, the number of processors used by the operating system, and the location of temporary folders. The environment variables store data that is used by the operating system and other programs. For example, the Windows environment or Windows directory environment variable contains the location of the Windows installation directory. Programs can query the value of this variable to determine where Windows operating system files are located. And you can see that in the software environment tab. And it will have all kinds, as you can see, of information that you can look at. Next, we can talk about the resource monitor. And this is where you can kind of get an idea on how much resources different processes are using on your CPU. And you'll be able to see the process ID, the name, how much CPU is actually being utilized, the description of the process, how, the status of the process itself, how many threads are being run. So this is a pretty comprehensive breakdown of processes that are running, and that can be very, very handy when trying to troubleshoot resource-intensive tasks that might be bogging your system down. There's a number of categories here that are really just giving you different information pieces about running tasks, but definitely work your way through here in case this is, something that you're going to want to work with in the future while trying to troubleshoot different programs that are running on your system. Again, this will show everything from both the CPU, the network utilization, the disk utilization. It's pretty awesome. Next, you have everybody's favorite thing, the command prompt, and this is where you can input commands into Windows. Some basic commands is who am I, similar to on Linux, where it basically will just return what user account you're running as. The host name, which will return what the name of the actual machine is. On Linux, we typed in ifconfig to get the IP address of our system, and other networking information. But on Windows, you type ipconfig. So a little confusing, but it'll basically display all the same stuff.
stuff. If you want to check ongoing network connections, you can use the netstack command, and there's a number of flags that you can use to get specific pieces of information. And there's even more commands that you can use in Windows that are all pretty awesome. But before we wrap this up, let's talk about the registry editor. This, as Microsoft says, is a central hierarchical database used to store information necessary to configure the system for one or more users, applications, and hardware devices. The registry contains information that Windows continually references during operations such as profiles, applications installed, property sheet settings, the hardware, and ports being used. So a pretty comprehensive breakdown, and that's really handy to be able to get information on users and other things like that. TryHackMe does leave a warning here that this is used for advanced usage, and making changes can affect the normal computer operation. So definitely bear that in mind when you're trying to make edits on here, that you're actually going to be impacting how the machine functions. So definitely be careful, make sure that you know what you're doing while you're making changes. And that will be the end of part 2. So that let's jump into Windows updates, a very important factor with Windows security. Some of you may be familiar with the term Patch Tuesday, and that is a great way to make sure that you are standardizing when and how often you are patching your systems, and you can do that in Windows Update. Now, Microsoft regularly releases updates, and so you can actually automatically install those updates, but in large environments where different updates might bring configuration problems to your environment, it might not be a good idea to have automatic updates on. But for personal use, just, set it and forget it. Make sure that your machine is running and you'll be good to go. But you can check that out in the settings, and then you'll see updates, and then you'll see update and security. I like that they pair those together. You can check for updates, but it will tell you if there are no updates available, which is what you want to see. If there is an update there, install that update. Install that right now. And along with updates, let's talk about security. Now, by default, you will have Windows security and its own kind of built-in security system, but you can also install third-party apps like McAfee and other kinds of apps, and those will integrate pretty well, but you won't necessarily be worse off if you're also just using the standard Windows security as well. Here you get, kind of all the things you like to see. You get virus and threat protection, a firewall, app and browser control, and device security. It's not bad. You can also customize which one of those you want turned on and off. I obviously would recommend turning all of them on, but sometimes people turn things off, and that's how attackers get in. So let that be a lesson. But let's dive into virus and threat protection. You can run virus scans from here, so that's pretty cool. You can run quick and full scans. Really, that just means that quick will run the commonly used and important folders, and full will run every single folder on your machine. And basically what that's looking for is it's looking for threat signatures, or basically unique bits of code or identifiers to malware that have been shared amongst the world pretty much by security researchers. And that will tip your computer off to the presence of certain malware. Now, know that that isn't perfect. On things called 0 days, which are 0-day vulnerabilities, meaning they're very new, they're brand new, there may not yet be signatures that have been shared for those, especially if it is, extremely new. Usually signatures are released pretty quickly, but again, just know if it's a novel kind of malware, it may not get picked up on a scan. But this will not only scan whenever you tell it to, it might scan on regular intervals, it might scan folders that you're installing onto your system. It's a good idea to leave this turned on. Next, you have firewall and network protection, and by this point you should know what a firewall is, but if you don't, the firewall basically filters network connections and other kinds of things. But we did cover that already in this playlist, so if you aren't familiar, just go through the TryHackMe Pre-Security playlist on my channel, and I'll link you to it actually at the end of this video. But you get one on here, so that's pretty rad. You can also customize the firewall and make sure that you can have an allow list and a block list. That's not bad. Next, let's go to app and browser control. And this will basically allow, Windows security to be able to check for files that might be installed or links that might be available to click on in different apps and your browser. And that will basically keep you secure while you're browsing online. If there's a link or file that they believe to be malicious or suspect, they will warn you before you actually click on it, or right after you click it and before you are actually connected to the destination. Another good thing to keep enabled. Next, you have device security, and this basically shows how your device itself is maintained. And as they mentioned here on TryHackMe, you're probably not going to either need to or want to change a lot of these settings, but we'll cover it. You get core isolation, which is good for virtualization. You get security for your processor, and you can also get some information on your processor. Next, BitLocker, and this is also very, very important, and that will encrypt your file system anytime you are not using your computer. So say your computer gets stolen, the attacker will not be able to access any of the sensitive files or folders or anything on your machine because everything is encrypted. And you will basically input a BitLocker pin or a passcode or passphrase preferably whenever you're logging onto your machine, and that will decrypt the BitLocker drive for your account, and then you can access your machine. This is a great little layer of security that you absolutely should have turned on. Next, you get the volume shadow copy service, and this can be a great way to get snapshots of your machine. So in case something gets corrupted, you can restore back to a shadow copy. So this will basically specify, when you want to create, your restoration image, when, you can perform that restoration, you can configure how you want the restoration to occur, and you can also delete the images themselves if they're starting to get too bulky on your machine. It's a great little added layer of security for your system that you probably might want to have.
We're going to be going over Linux Fundamentals Part 1. Part 1 really acts as the intro to Linux section. Part 2, we dive a little bit deeper into Linux, and Part 3, we dive even deeper into Linux. And by the end of the 3-part series, you'll have a fairly good understanding on Linux operating systems. But this is all on TryHackMe. You can work through these rooms if you'd like on your own. There are some practical exercises as well, and that would be a great way to be able to test your knowledge, so I highly encourage you do that. But with all that said, let's jump right in. First, let's go over a bit of a background of Linux, and they talk about the background of Linux here on TryHackMe. If you're not already familiar with Linux, it's an operating system that is utilized in just about every facet of your life, whether it's point of sale systems, oftentimes corporate networks run on Linux, IoT devices more than likely run on Linux. And the reason is Linux is just a more lightweight operating system than other operating systems like Windows or Mac OS. It's also easier to customize because it's open source, which means anybody is able to make changes to the operating system to fit their needs, as opposed to Windows or Mac OS, where if you want to make a fundamental change to the operating system, you might be out of luck. Now, there are many different flavors of Linux. If you're watching this and you're part of the cybersecurity crowd, then you're probably familiar with Linux and Kali Linux and Red Hat and some of the other security-centric distributions of Linux. However, everybody should be familiar with Ubuntu, which is a good general-purpose distro of Linux. CentOS and Apache are also great utilizations and deployments for Linux. But for this room right here, what we really want to understand is who invented Linux and when. And we can credit Linus Torvalds as the main creator of Linux back in 1991. Now, on the next tab, if you're following along, you'll have an opportunity to be able to deploy a Linux server and connect to it in your browser. So go ahead and do that right now. Now, the real power of Linux can be unlocked whenever you understand the command line interface, or the CLI. And there are some very basic commands that we're going to learn right now off the top to be able to know how exactly we can interact with our environment. And TryHackMe gives us two separate commands right here, echo and who am I. Echo will quite literally echo a string that you give it. So for instance, if you echo quote, who am I, it will echo who am I. That was a terrible example because of the next command, who am I? If you type in who am I, the CLI will reply with the user account that you are currently logged in as. Go ahead and put those answers down into the answer box. Now, how is it exactly that you can navigate the file system? Because whenever you open the CLI, you're actually sitting at a specific point in the Linux file system. To figure out where exactly you are, you can type in PWD. That's short for present working directory. And it will tell you the path or the exact location in the file system that you are at now. You can type in LS, or short for list, to be able to find the different files or folders that exist in your current location. And then you can do CD or change directory to be able to change either backward, forward, or into one of the files in your directory. CD ... actually will take you back one directory. You can also change your directory to a specific location. So if you know the file path of a specific directory you want to go to, you can do CD and then type the path of that directory you want to go to, and you will go right there. Next is cat, and the full name here is concatenate, and that will basically view a file that you have permissions to view. So for instance, say there is a note in your present working directory called mynote.txt. You type in cat mynote.txt, it will pop up hello world. Hi file. Now let's try searching for files. Say that there is a specific file on your machine that you're looking for right now and you don't know how to find it. In comes the find command. This command is so handy because it allows you to be able to find pretty much anything that you are looking for. For instance, if you're looking for a file with a specific name, you can find it. If you want to find files with a specific permission set, you can find that as well. There are a number of different flags that you can put with the find command. You can see that right here on the screen. But basically, all you need to know is that you can type find -name and then type the name of the file you're looking for. Find -name like button. Next, we're going to talk about grep, and this is also a very handy command. Grep will basically search the output of your previous command or search and look for something specific that you give it. So the example here in TryHackMe is you're looking through access.log, and it's going to have a ton of different logs in that log. So say you're looking for a specific IP address like the one it shows here. You can grep the IP address as a string, and it will search that access log and then show you all the different lines that IP address appears in. Pretty handy. There's also a flag that you can find in this room, so I'll let you find that. Next, let's talk about shell operators, because these can also be a powerful tool to be able to use on the CLI to really extend the power of your command. For instance, here we got and then we got some less than sign or greater than sign, whatever those are. I'm not good at math. The single and command will allow you to run the command in the background. The double and will allow you to combine the commands. The single greater than sign will actually redirect the output of your previous command. For instance, say you want the output to be input into a TXT document or something like that, then you can use this operator to do just that. And then you can use the name of the document you would like that output input into. Output, input, output, in. Whatever. The double greater than sign actually will append the output to whatever's in the document. So if you use the single greater than sign, it will actually delete everything in the file and replace it with the output of your current command. If you use the double greater than sign, it will just append it to the end of the file. Important differentiation. And that is pretty much all you need to know about Linux Fundamentals Part 1. On the last video, we talked about some basic commands that you can use, but generally on every command, there's a series of flags and switches that you can use to be able to also specify your command a bit further. For instance, we're talking about flags and switches for the list command or ls. You can do ls-a or all, and it will also list the different hidden folders, which are folders that have a dot in front of them. You can also type in the command that you wish to use -help or -h, and the output will be basically all the different flags and switches that you can use in your command. That's a handy tool that you can use if you're brand new to a command and you're trying to figure out your way. There's also what's called the man command or the manual command, and that will show you basically the help manual for any given command. Next, let's talk about some more commands that you can use in Linux to be able to interact with your file system. Say you want to make a document. You can use the touch command. So touch and then the name of the file that you wish to make. You can also make a directory. So you can type in mkdir or make dir, and then you'll be able to make a directory. You can also copy things. So CP or copy, and then the name of whatever you wish to copy. You can move things, so MV or move, the name of whatever it is you wish to move, and then the destination. You can also remove things, so you can type RM and whatever it is that you want to remove. Word of caution on this, sometimes you may not have permission to remove specific items in a directory. And so if you have sudo permissions, you might have to pull out sudo with RM. And in other cases where it's a directory, you might also have things inside that directory that might also need to get deleted as part of this process. But you can also recursively do that with the remove command, but I'm going to let you find that out by typing in rm-h in your CLI. Next, you can type in file, and that will really show you what type of a file something that you search for is. Next is permissions, and it's important. This is generally across most operating systems. There are 3 different types of permissions: read, write, and execute. If you have permission to read something, then you can open a file and read it. You can access the information. If you have permission to write to a file, then you can actually write things and delete and manipulate the file however you want. And if you have permission to execute, then you can execute different executables or programs or applications on a system. Not everybody should have all three. And that's really where IAM, or Identity and Access Management, come in. And that's kind of a routine process. That's where a lot of the full-time jobs for sysadmins and net admins, that's really a lot of what they're doing, is they're manipulating people's permissions to be able to make sure that people don't have too many permissions and people have just enough permissions to be able to get their work done. There's also something called sudo, and that allows you to basically run commands as an admin. Now, not every user will have full sudo permissions. However, some users might have more sudo permissions than they should, and that is how attackers are able to escalate privileges. That is a whole can of worms. So comment down below if you want to see me dive into that a bit more in a later video. Finally, it might be helpful to know how to switch users, and that's where the SU command comes in. SU, the name of the user that you want to switch to. It is that simple. That said, you need to have permissions to be able to switch users. But whenever you do that, you will actually be able to switch over to that user and inherit their permissions level. Next, let's go through some common directories. /etc, that's going to have quite a lot of stuff in it. Really, all of these will, but Etsy sure is. /etc stores a lot of important files in your operating system. There's also quite a lot of cool tools in /etc, so feel free to take an exploration trip down there. /var basically stores a lot of the frequently accessed files by applications in the operating system. /root is the home folder for the root user, and the root user is the top dog. They have all the permissions, full control over the operating system. So really, you should not be running things as root, because if you break something, it's broken. You've broken it. And then /tmp or temp, and that's basically a temp file that stores random stuff that you might need to have in a given session, but it's not permanent. It is cleared out. So that is Linux Fundamentals Part 2. To this point, we've learned a lot about how to interact with and navigate through the file system. But let's say you want to edit something inside of a document, and you want to edit basically the contents. That's where text editors come in the terminal. Now, there's a number of different types of text editors on Linux, but the two main ones that you'll find most people use is Nano or Vim. Personally, I'm a Nano guy, and a lot of you watching this video might judge me for it, and that's fine. Leave me a comment about that. A lot of people say that they use Vim, but no one's seen them because they haven't figured out how to exit Vim. Leave a comment down below if you have managed to exit Vim, because that's important. We need to know that people have survived. But in reality, both are very solid text editors. Vim requires a little bit more of a commitment to memory. Nano displays a lot of the key bindings down at the bottom of the screen, but both are very good to use. So there's really not much of a difference in either case. But to be able to use either one, you can type nano and then the name of the file, or VI in the name of the file. Now, say there's something that you don't yet have on your system and you want to get it, you want to download it. You can use the wget command and then a link to the file online that you want to download. This might require some sudo permissions depending on what level you're using this as, but that's basically the command. Now, say you want to be able to copy a file over to another host over SSH. You can use the SCP or the secure copy command. And here on TryHackMe, you can see how exactly you can craft a secure copy command. And basically goes SCP, the name of the file that you want to copy over, the user of the remote system, at the IP address of that system, colon, and then the path to where you want to store this system. Now, say you want to copy something over from a remote system, you can do basically the same thing, but you can do SCP and then that whole long line about user, IP, and then path, and then the name of the file as you would like it to be saved on your system. So basically, if you're sending it out, you're going to include the name of the file that you're sending first, and then if you're copying it over, you're going to include the name of the file that you want it to be saved as last. Now, sometimes you might want to host your own web server on Python so that way you can retrieve it from other machines as well. You can use Python for that. So, for instance, you can use Python 3-m http.server, and then that will open up an HTTP server, and it will open up a server on the default port 80 port on your machine. Now, mind you, it will do this in the file system that you are hosting the server on. So it might be helpful to create a dedicated folder to run this server, and then make sure that only the files and stuff that you need people to access is in that folder and nothing more. Let's get into processes. And this is where things get a little confusing for me, but it's okay. We're all on this together. Every operating system has a number of automated processes that are running 24/7. 7. Most of those are just the random chores that your operating system needs to execute just to run, and they're fairly innocuous. But sometimes there might be processes that you do want to kill because either they're taking up too much CPU or they might be malicious. Now, each process is given a unique identifier, or a PID, a process identifier, and that's basically how you can make determinations on if you want to kill it or not, is using the PID, and then you just know which process to kill. So if you type PS in, then you will see a list of processes, and that shows the list of processes running under your account. But if you want to see all the processes running on the operating system, type in PSAUX or PSAUX, and that will show you all the processes running on your machine, as well as who owns each process. You're going to see a lot of processes owned by root, and that's fine, as long as they're not malicious. So you do probably need to know about the common processing. Another command you can use is the top command, and it will show you the top processes that are being run on your system. Now, say you see a process that you don't like, you can type the kill and then PID of whatever it is that you want to kill, and it will kill that process for you. Now, there's a lot of times that you'll want to create a process or create an application or something like that you want to be able to start as soon as you start your system. And so that's where you can use the system control command to be able to tell your system that as soon as you boot up, I want this system running. For instance, let's say you want to run an Apache server, and it has the example here on TryHackMe, but run system control or systemctl start Apache 2. And optionally, if you want to stop it, you can type systemctl stop, or say you want to restart, systemctl restart. There's also enable and disable, and enable and disable basically toggle whether or not that will start up or not start up on system boot. Now, you might have a lot of tasks that you want to run automatically, and that's where cron tab comes in. Cron tab is pretty cool, and it allows you to schedule specifically when and what frequency you want different command line commands to be run on your system. And it is incredibly easy to use. You literally just front load the command with the time frequency, and then you put the command that you want to run at the end. It's that easy. It's so awesome. And you can literally edit cron tab anytime by typing in cron tab -e, and it will show you all the different cron jobs, and you can edit it from there. Next, let's talk about repositories. And this is a great topic to talk about, especially if you want to make sure that your operating system has the functionality that you're looking for. And that's where the apt command comes in. For instance, the command add-apt-repository, and then the name of the repository that you're wanting to add, that really is something that you can use. Now, TryHackMe goes through a lot of the detail here and how exactly you can add repositories, but I think it's very important to understand that keys are important, and being able to have the correct key will really make or break how you can get the repository added. After all, you want to make sure that you can trust wherever you're downloading from. Once you have the key downloaded, you want to make sure that you have it added to your trusted list, so that way your machine knows that it's trusted, and then from there you'll be able to download the repository itself. Another important command that you should know of is apt-get update and apt-get upgrade, and those will basically update and upgrade all of your repositories to make sure that you're running the most recent version on everything. Next, let's talk about system logs, and everything's going to be stored for the most part, unless you specify otherwise, or in /var/log. This is an important place, especially if you're working with logs for your job. You'll want to be able to know where these logs are so you can ingest them into something like a SIM or any kind of other program that you're using to be able to work with these logs and identify any kind of issues that need to be found in these logs. Another command, if you're not using one of those tools while working with these logs, is grep. Open the log, grep for something interesting, and maybe you'll find it, maybe you won't. But really, for the most part, the amount of data that appears in var log it really balloons very quickly, and that's where a SIM can be really helpful. And that's part 3 of Linux. So by now you should be fairly familiar with the Linux operating system. On this video, we kick off Windows, and that's another 3-part series that you should be familiar with. We're finishing up the TryHackMe Pre-Security pathway, and this is a playlist of all those videos up to this point. So you should try it out. It's nice. With that, we'll see you all next time. Bye.